Hey, how's it going?
Hi, it's going well. Welcome.
Hey, how you doing?
I'm doing well.
Good,
I'm
good.
trying to get some practice interviews in before my on-site coming up.
Oh, nice. Good luck.
Thanks.
Yeah, I'm just practicing just to keep my skills sharp.
That's
So,
good. It's important.
yeah. All right.
All right, so it looks like you're answering the question first.
Mm-hmm. Okay, shifted array search. So, I'm just going to read it out loud.
Okay.
A sorted array of distinct integers, shift array, is shifted to the left by an unknown offset, and you don't have any pre-shifted copy of it. For instance, the sequence 1, 2, 3, 4, 5 becomes 3, 4, 5, 1, 2 after shifting it twice to the left. Given shift r and an integer num, implement a function shifted array search that finds and returns the index of a num in shift array. If num isn't in shift array, return -1. Assume that the offset can be any value from 0 to array length -1. Okay.
Mm-hmm.
So looking at the example, so we're given the number 2. So basically we're trying to find num in the array that's shifted and return what the index is. So in this
Yes.
case, 2 is 0, 1, 2, 3. Okay. So if it wasn't shifted, we could just use a normal binary search
That's right.
and just find it that way. So I think we can utilize that, but we kind of have to modify it a little bit.
Mm-hmm.
So it seems like both. So in this input or the example, we basically have two sorted arrays. So
You mean the sorted array 9, 12, 17, and then 2, 4, 5?
right. So if we can somehow figure out which side that our number is on, then we can just do a binary search on that side.
Mm-hmm.
Does that seem like a good approach?
That seems like a fine approach. How would you figure out what side your number will be on?
Yeah. Um, so at any point where we have a number and then the index to the right of that is smaller, that's going to be called, like, let's just call it like our pivot point or our shifted point.
Okay.
Um, so we could do like, we can do, I guess we could do two binary searches. One is to find the pivot and the other is to actually find the index. Um,
Yeah, you could do that.
yeah. So I guess, so in this case, if we did a binary search, I'm just going to copy this over. Oops. So our size is equal to 6. Our midpoint would be 6 divided by 2, which is 3. So we would get to 2. And let's see. So the right side, or at index 4, the number is still greater than it. So I'm trying to figure out which side we would search now at this point. I guess that's the tricky part.
Well, you know that at index 3, the value is 2, which is less than the starting value. So you know that
Mm,
the pivot point would be to the left of 2.
right.
Or you
Yes.
could consider the pivot point to be 2. It depends on how you want to define it. Do you want to define the pivot point as the very final spot in the first array or the very first spot in the second array?
Hmm. Yeah. So I guess it depends. So like in this case, our num is equal to 2. So once we see that, yeah, you're right. Once we see that 2,
I mean, because in this particular case, the number that you're looking for is also right on your pivot point, which is also the first place that you're checking. So there's a whole bunch of stuff that can happen.
right. So you're saying I could check the number before?
Well,
Also.
you could, but is there any way? But you talked about breaking it up. So you talked about finding the pivot point first, and then searching once you found the pivot point. So you find the pivot point, and then you search the proper array once that pivot point has been found.
Right.
So let's go back to they're talking of finding the pivot point and talk about how you would find the pivot point specifically.
Yeah. So maybe instead of checking against the number to the left or the right of it, like you kind of mentioned, we could just check against the first index. And at that point, I think we know which side we're on. So like, okay, so if we're at this 2, we'll check against 9. So we know that we're to the right of the pivot at this point. However, if we were at 17, we would check against the 9, and we'd know that we are still on the left side of the pivot. So we just need to check like the opposite side.
That makes sense. In this particular case, though, when you find the pivot in this array, what would you return for the pivot?
Um,
Would you return 2 or 3? And why?
I mean, in this particular case, since we're looking for 2, we want to probably.
But right now, you're just trying to find the pivot. So it's two kind of questions that are broken up.
Right. I guess it doesn't matter which side, as long as we just remember which side of the pivot that we're on, or that we're keeping track of.
Okay.
I think we just need to pick a side and then just use that.
Sure. Which side do you want to pick?
We can pick the right side.
Okay.
Yeah.
So in this case, it would return 3 then for the pivot point.
Right. So yeah, our pivot would be equal to 3. So then now when we do, so I guess at this point we need to check. So I guess the algorithm would kind of be like get the pivot point, check which side of pivot num is, and then like set the new logical boundaries, and do binary search there.
Yep, that's it. Why don't you start off by writing the helper method of get pivot?
Mm-hmm. Sure. So okay. So I guess we could do this iteratively. So we could have our beginning equal to 0 and equals shift array dot length minus 1, and then we could do while beginning so let's get our middle point. Okay, so now that we have our mid, we said that we were going to check against, so I guess it could be 2 things. So initially we're going to check if, let's see, if the point that we're at is, I guess, let's say if it's greater than shift array 0.
Okay. So the point that you're at is greater than the far left point. That tells you that you are to the left of the pivot.
Right, right. So we need to check so we need to set our beginning equal to mid plus 1.
Okay.
Otherwise, we need to set the end equal to mid minus 1. But how do we figure out
So you have ways to
go left and right, but I don't have a way to find where the actual pivot is. So maybe at this point we should do a check. But first we should check if shift array mid is less than, and are the numbers distinct?
You can have duplicates.
Okay, let's just assume they are.
I mean, it doesn't specifically say that you can't have duplicates.
Yeah, I guess.
Imply that you can. So assume that you can.
Okay.
If I were to give you the array with 0, 1, 1, 2, that would count.
Okay, so it would just have to be. So if it's left, then shift array. So shift array mid plus 1. Then we just return. Actually, sorry. If
it's always going to be less than the mid plus 1.
Yeah.
Unless you are 1 point to the left of your pivot.
Yeah. So if where we're at is greater than, yeah, then we can return mid.
Okay.
Okay. Do you want to try? I think we have I think there's one other edge case. Is what if we're at the last one? Then we don't want to do mid plus 1 because then we'll get out of boundary.
That's right.
Exception. So shift array, or let's just do if mid equals dot length or oops, what did I do? 4. So for there, or okay. Do you want to try to test this helper method?
Yeah,
here?
that'd be a good idea. Think of some good test cases.
Yeah. Print. So let's just use the one that they gave us. So let's see. Missing return statement. Oh. I guess at the
your get pivot doesn't have a return statement that it's guaranteed to hit. It could, if for all Java knows, you could be stuck in a while loop for that while loop could never hit.
Yeah. Like this if statement might not ever hit.
Yeah, and I can actually think of an example where you're going to get an endless loop.
So okay. So at the end here, if we never get anything, say we have like maybe 0, 1, 2, 3, 4, would that ever? Yeah, it never would hit the array. So at that point, we probably
1, 2, 3, 4. It's going to return 4. That'll hit.
1, 2, 3, 4. Yeah. What do we return here? Let's see.
Can you think of an example where it would never return anything? Where mid doesn't equal shift array dot length or
well, if we have like one element, I think it would hit because our mid would just be 0.
If there's one element, what would happen?
If there's one element, our mid would be 0 and it would equal Actually, it wouldn't equal 1.
What if it was an empty array?
Yeah, I think actually even if it's one element, because our mid would be,
your mid would be 0 plus
0, and our
0.
length would be 1, so it wouldn't hit.
Right. So
at this point, we probably want to return 0.
yeah, that's good.
Yeah. All right, let's run that. Oh, I think it's let's just return 0 on this one for now.
Oh, I didn't even notice that part.
Yeah. All right, 2. That looked right for that example. How much time do we have? Okay. Let's just try like 1, 2, 4, 5. Failed. This compiler kind of messes up sometimes for no reason, so let me try running it again.
I don't know. I haven't done an example here for a long time, but it says it failed on line 8.
Yeah, I'm not.
And that's what it's getting. It's getting an array out of bounds exception.
But I never even call that method. So I'm not sure.
Well, I mean, I think it's getting an array out of bounds exception, not on line 8, but I think it's specifically getting an array out of bounds exception that's happening on line 19.
I wonder if the while loop is right. Like this beginning, would it be greater than or equal to n, or would it just be, or less than? Would it just be less than?
Normally, it's just less than.
Yeah. I bet you that's what's it. Okay.
It returns 0, which is correct.
Yeah. All right, let's move on to the next part.
All right.
So at this point, we will call get pivot on shift array. Okay.
Okay. So now that you know the pivot,
Let's just call this. Yeah, let's call it pivot. So yeah, like I said here, we're going to return which side it's on.
Okay.
If how do we want to do this? So in this example, our pivot would be 0, 1, 2 at index 3. Maybe this isn't the best example. So if we go down here, let's say our number is that we're looking for is 4. So we would say so the number will always be greater than our pivot, right? Because our pivot is now the smallest number.
Right.
So we want to check if our number is less than the last element. So
is it less than the last element or less than the first element? What if your number equals the last element?
Yeah.
What if you're searching for 5?
Right. If it's 5 and we're searching for 5, can we do less than or equal to? Maybe not, because we said there might be duplicates. So there could be a 5 at the beginning and a 5 at the end.
And what would you do in that case?
So
what if the array?
Well, I guess that wouldn't make sense because we don't know which 5 we're looking for.
What if the array was 5, 9, 12, 17, 2, 4, 5?
And our number was 5? Well, we wouldn't know which one.
But what are you supposed to return? You're supposed to return a location in the array where it's included. So you can return either.
Okay. Yeah, I guess I could check against. I can check if it's greater than or sorry, less than or equal to the last element.
Okay.
So if num is less than or equal to shift array length -1, then so we want to have our new like logical start and end. So let's start end. So if it's less than, then we want our start equal to our pivot and our end equal to shift array.length -1. Otherwise, we want to set it to start equal to 0 and our end equal to pivot -1. And then once we have that, we can just do our binary search.
Mm-hmm.
So binary search array start and end, and that's what we're returning. And then I just need to implement this. So oops, static. I don't know if Java has a built-in binary search, but
it does.
I think it does, but I don't remember how to call it. So
yeah, in the time it would take you to look up how to call it, you could just write it yourself.
Yeah.
We only got 6 minutes left.
Okay. So it's going to be similar to what we did earlier. So we'll say, so while equals, just going to copy that. And it's going to be similar here, so I'm going to copy that as well. So if shift array mid equals, we also need our num here, so and we need to pass that in, num. And then we also need the case where we don't find anything. In that case, we're going to return -1. Oops. All right, so let's try that.
Okay.
So that, and then 2.
Line 15, semicolon expected.
Mm.
There's a semicolon there. Oh, yeah, actually,
Wait, did I?
Mistake on line 15. You have a syntax error. Yeah, there.
Yeah. Oh, did I?
Are you used to writing in Python?
No, actually, I usually write in Java.
Oh.
I don't know why I wrote it like that. Line 27. Oh, wait, why is it?
You have beg instead of start.
Oh. Let's just change it here. Big and. That's what I get for copy pasting.
There you go.
Okay, 3. That looks good. Let me run tests.
I don't think it's going to pass all the tests.
Oh, didn't pass any of them. Let's see.
Notice what it's returning for all of them.
It's returning -1 for all of them. Why is it doing that? Wait, it's expected. Oh, okay. Yeah, it is returning -1. Oh, because so I am returning. So I set mid here. And then if shifted array mid.
Surprised it failed all of them. I would have thought there would be at least one test where it wanted you to return -1.
Yeah. So if shifted array mid equals num, then return mid. But because it worked on the example that we wrote. And in fact, if you look at test case 5, is it the same? No, it has 17.
Yeah, 9, 12, 17, 2, 4, 5. That's the exact same one.
But it's asking for 17. So let me try running it with 17 and see what happens.
This Java thing is slow.
Yeah. See, it even timed out. Did return -1 there. Interesting. Did I mess up with the pivots? With this. So if num.
I think that I actually don't see the exact spot that there's a mistake, but I know there must be one. Otherwise, that would not be compiling wrong. Before we go on to switch roles, do you want to talk a little bit about the big O of this?
Yeah. So let's see. So initially we're calling shifted array search. So we do a binary. So get pivot is a binary search. So that's log of n.
Mm-hmm.
Then we're doing this constant time operation with this if statement. And then we're doing another binary search. So it would just be log of n for the big O.
That's right.
Yeah. And then we're doing everything. We're not doing anything recursively or anything. So the space here would be constant.
Mm-hmm.
Yeah. All right. Yeah, I'll have to take a look and see why these are returning -1. It might just be, I think, maybe just something small.
It probably is something pretty small.
Yeah.
I bet if you reread it from scratch, it would just work.
Right. Okay. Right. Cool. Let's switch. Yep.
BST successor search.